Hi, my name is Joe, and today my partner Abhay and I will show you how to solve a real-life problem using principles learned in our physics class. Before we begin, first we'll show you a clip of the problem in action.
And this is the big American Brian Shaw out of Colorado. He's in third place in the overall standings after that first event. By all rights, he should have won it, but remember, he dropped the sack and he had to reset it. And at 6'8" and 405 pounds, Phil, he's got plenty of power.
Just goes back to the fact that strongman is a big guy sport, and there's none bigger than the Big Shaw.
In this scene, the wall is 4.42 meters tall. The competitor is standing approximately 0.91 meters from the base of the wall.
These kegs are 53 pounds, and for Brian Shaw, not a problem. He sets the new fastest time.
Now this is the word problem version of the video you just saw. The problem is a world's strongest man competitor tosses a 24 kilogram keg over a 4.42 meter wall. The keg reaches the ground 2.12 seconds later. If the competitor was standing approximately 0.91 meters from the base of the wall, what was the initial velocity of the keg? First, I'm going to start by drawing the problem out. We have 0.91 meters, which is the distance from the base of the wall to the position of the competitor. 4.42 meters is the height of the wall. As you can see, we actually have to find the angle at which the competitor threw the keg. To do that, we will use the inverse tangent theorem. The angle was 78.37 degrees. And now I will forward the problem to my partner Abhay, who will elaborate on the rest of the steps.
So now that Joe has completed step 1 and 2, it's time to gather our information and put it in our X and Y table. So I'm going to start with acceleration, position, velocity, and time. So let's look at acceleration. Acceleration in the X direction is unknown at this point. Acceleration in the Y direction is negative 9.8 meters per second squared due to gravity. The initial position in the X direction is 0, and the final position in the X direction is 0.91 meters, which is the distance between the base of the wall and the position of the competitor. The initial position in the Y direction is 0, and the final position in the Y direction is 4.42 meters, which is the height of the wall. The initial velocity in the X direction is unknown, and the final position in the X direction is also unknown. The initial position in the Y direction, the initial velocity in the Y direction is unknown at this point, and the final velocity in the Y direction is 0, because the keg has reached its maximum height, and so therefore it has no vertical component, but it's still moving horizontally. As far as time, so when the keg was tossed over the wall, it has created a parabola. So we know that a parabola is symmetric. So for example, if I throw a ball in the air and it takes 3 seconds to reach its maximum height, it's going to take 3 seconds to reach back into my hands. So based on that information, we can take the time over here, which is 2.12 seconds. So if the keg takes 2.12 seconds from its starting position to its ending position, we can divide that by 2 and get 1.06 seconds. That is how much time the keg took to reach its maximum height. So our time is 1.06 seconds. So now that you have put all our information in the X and Y table, it's time to find an equation, a kinematic equation, to find the initial velocity in the Y direction. Here's some kinematic equations for this particular projectile motion. I'm going to use the second one. So we plug in all our numbers from our x and y table that we created in step 3. So if you solve for the initial velocity in the y direction, we get 9.37 meters per second. Please note that this is the initial velocity only in the vertical direction. However, we need to find the initial velocity as the keg is being tossed at an angle of 78.27 degrees. So for the final step, let's redraw a diagram. We know that the theta is 78.37 degrees. And from step 4, we know that the initial velocity in the y direction is 9.37 meters per second. But we need to find the initial velocity at this direction. So using sine theta equals opposite over hypotenuse, we can find our initial velocity. So initial velocity equals 9.37 meters per second over 78.37 degrees. So the initial velocity will be 9.57 meters per second. So the keg was tossed at an initial velocity of 9.5 meters per second. So to clear the 4.42 meter wall, no matter the weight, the competitor has to throw the keg at least the initial velocity of at least 9.57 meters per second.